Hello, this is Clayton with Aeromotive Research and Development Group. Today we're having another presentation, coolant system performance presentation for SynMax University. If you have any technical questions, please get a hold of us at office@aeromotiveresearch.com. Today we're going to be speaking about the coolant system pressure control and metal surface protection with qualified chemistry. This is an important presentation. So let's begin. A common historic problem is how do we control unwanted alloy gases and unwanted pressure? Here's what happened. In 2015, a NASCAR racing group, an engine builder with multiple team championships as a constructor located in Mooresville, shipped a car complete to the team to California for racing. The car was fully prepared with all the components required. It was a new engine with a race car, NASCAR designed radiator. It was clean with one race. But at the track, when the car was unloaded and rolled into the garage, the team noticed a problem. During the pre-practice and race preparations, before the car was even started, the coolant system pressure was at 35 psi. Again, before they even started racing, the system was at 35 psi. Well, the question was this: how did a fully prepared professional race car just sitting have 35 psi coolant system pressure? You see, the problem of this has happened many times in multiple different applications without resolution or an answer. See, what we have to understand is this happened from alloy gases, and alloy gas pressure is separate from system pressure under automotive mechanical operations while the engine is running. It's gases that come out. Let's get into this. Now, we want to control this air bubbles or this alloy gas situation. See, air bubbles within the system have 10 times the compressibility of strength as compared to regular fluid of oil or water. It's like steam power. When you harness high PSI power, the steam, the air bubbles, and the steam within the engine or turbine create power and efficiently control for the use, like a steam engine. But you see, in an automotive and racing coolant system, you want to control alloy gases. You don't want any air bubbles or pressure going on, all right? And so with a qualified fluid, you want a qualified fluid which protects all metal surfaces from the aluminum alloy gases, which is also the ability to dissipate air bubbles or foam, all right? If you cannot control this, the per square inch pressure will be out of control and it's bad. You see, coolant system pressure and the cleanliness problem has been solved. All right. You say, well, here's the problem. Well, who solved it? Well, the IndyCar Series manufacturer, multiple champion, solved this pressure problem by using a qualified coolant chemistry with distilled water under procedures, under special technical directive to the team since 2012. Well, what is this? Well, it was the water cooler concentrate. That's why. But we'll get into that in a minute. You see, it's called they're metal vapor bubbles, all right? It's called aluminum alloy gases or metal hydrates. You see, as alloy metals are molted and created, hydrogen is stored. The hydrogen is stored within the metal process. In the creation, it's called metal hydrates. Metal alloys decompose as they are subject to heat and electricity and conductivity. Now, aluminum is very heat sensitive and an electroactive metal. The hydrogen, which is originally trapped within the metal when it was created, is released like a water vapor. This process is called physical vapor deposition. Okay? Metal hydrates greatly accelerates the aluminum corrosion process. Further, unremoved from these small hydrogen vapor bubbles on the metal surface creates or forms an insulating layer which impedes and stops the heat transfer process. If a qualified coolant chemistry is not used, the metal surface or the aluminum will not be treated for protection. And then under heat, the alloy gases or the metal hydrates from the aluminum are released. And then these alloy gases create standing coolant system pressure. You do not want this pressure. Now, aluminum is a flexible metal subject to expansion and contraction greater than steel. This opens the pores of the metal, If these pores are not coated with a proper chemistry, then the heat alloy gases or metal hydrates in the form of hydrogen bubbles will release into the coolant system with a strength of 10 times compressibility. You don't want that. All right? Here's why. Once the hydrogen vapor bubbles or alloy gases, if they will not disperse and they won't disappear. They will continue to be released and continue to multiply, further accelerating the damage of the metal surface decomposition. But metal hydrates can be controlled with a proper coolant system chemistry with it coating on there. You see, the goal is to coat and protect the metal surfaces of the aluminum, not to allow the alloy gases of the metal hydrates to escape. Metal hydrates can be controlled with a coolant system chemistry. In other words, they're telling you there is an answer to the problem. Now on the left, you've got radiator tubes that were protected with the SynMax Water Kooler Chemistry. Below, you've got a radiator with a common coolant treatment. The problem was, unless the specific issue for the aluminum steel metal is addressed by a chemical formulation decision, the metal surfaces will allow the hydrate vapor bubbles or alloy gases to release from the metal surface and increase the uncontrolled system pressure. Increased system pressure from the unwanted gases and bubbles will not disperse and disappear. The alloy will continue to release these gases and multiply, increasing pressure, creating internal problems, and eventually out of control and irrecoverable. Alloy gases also increase and accelerate damage to the metal surfaces for rust and corrosion. Now, another area that we got to look at beyond hydrates and metal gases is common nucleic boiling, which is centralized surface hotspots. All right, you've got nucleic boil to film boil, and it's a continuous thin layer which covers the heating surface and keeps the liquid cool from contacting the other surface areas. And if this is not controlled, it's a good thing to have a nucleic boil, a slight little sizzle, but if it overcomes, it will have what's called a heat soak and a full boil, and that's out of control. And if you add that with the alloy gases, you got a mess. Now, here's something that's important. If the water-metal surface tension is not reduced and controlled, these small vapor bubbles or hydrogen heat and vapor bubbles will increase the surface film. These unremoved small hydrogen vapor heat bubbles on the metal surface creates or forms an insulating layer which impedes and stops the heat transfer process. Once these vapor bubbles, for a variety of reasons, gets too active in the coolant fluid, it acts like steam. The coolant system is out of control and irrecoverable. The coolant system will not transfer heat BTU energy, and the PSI continually increases and it gets overboiled, turns into steam, and a real bad problem. Now, the problem has been discovered and an answer has been achieved. You see, a qualified multi-champion radiator manufacturer, which provides radiators for Formula One, Le Mans, FIA factory racing teams, NASCAR, short tracks, sprint cars, SCCA, Mazda, Indy Lights, etc., wanted to check out and have a solution for this, all right? Because many professional teams was presented with the problem of coolant system pressure and also coolant system cleanliness, all right? So since 2000, for 15 years, this radiator manufacturer was provided with over a dozen different coolant system products. And over time, none of these national brand coolant system products successfully protected the metal surfaces from the alloy gases to provide zero standing system pressure. Yet in 2015, the radiator manufacturer was provided a solution used by regional short track late model champions and further with success by an IndyCar engine manufacturer with multiple championships. So a test was conducted, a radiator system pressure test for a 5-time repeatability test to discover qualified chemistry to provide the metal surface, the aluminum, protection for coolant system pressure control. The radiator manufacturer conducted their own controlled radiator pressure system with a 5-time repeatability study, The test will be simple and basic for anyone to reproduce. You can do this in your own home, in your own shop. All right. And what it was is the goal. The number one goal was to use a common enclosed sealed radiator to hold and sustain and measure the pressure. Goal number two, simulate a 200-degree radiator engine operational temperature controlled. Goal number three, the radiator temperature would be sustained for at least 1 hour for 200 degrees Fahrenheit. And it was a 5-time repeatability study. Because of the use of a common kitchen oven, was preset at 200 degrees. A sealed standard radiator with the port areas for system pressure testing was provided. One time each day for a period of 1 hour, the radiator with designated product would be placed into the oven and heated to 200 degrees. At the end of the 1 hour session of the 200 degrees, the radiator would be taken out, allowed to cool to room temperature. The pressure was recorded. It would be taken and reviewed. Controlled test procedure would be repeated each day for 5 consecutive days. So it took 3 weeks. All right. And the water that was used was a common tap water that was, in the kitchen. So they didn't even use distilled water here. All right. And with a 5% treat rate for all products. Now, the additive products that was used was the SynMax Water Kooler, which is specific by the NDT manufacturer, and 2 other brands that we won't say the commercial names of. Now, the test purpose was to use the city water. Test purpose was to make sure we had 5% treat rate, and each one was controlled. All right. And we had the 1 hour, 200 degree situation, which was designed for sufficient time for continued heat cycle activation release of the alloy gases. In other words, hydrogen stored within the aluminum called metal hydrates. Bottom line, if the coolant chemistry worked as advertised, the metal surface, in this case the aluminum in the radiator, would be treated, coated, and protected. Alloy gases, in other words hydrogen vapor bubbles, would not be released or emit from the metal. Now, the end result was a better chemistry performance, and that would be good, less to little. Now, the end result, too, is reverse of the chemistry performance, which was more system pressure from alloy gases, which was bad. Now, the ultimate goal was to find a metal product surface conditioner that would allow 0 system pressure. So the qualified chemistry used was the water cooler. Now here's the results of that. After this 5-time repeatability test, the water cooler had 0 pressure. The second brand, which was red in color, had 12 psi of pressure. The other brand, a nationally known, advertised on NASCAR cars all the time, had 25 pounds of pressure. In the end, the SynMax Water Kooler had 0 pressure. The other brands was 25 and 12 degrees. This is a totally independent study from Aeromotive research. Therefore, the data as shown using the SynMax Water Kooler product provided maximum system protection. Again, this is simulated pictures, and this is what happens. All right. On the left, the metal. When you can have metal that's clean, or you can have metal that's rusted and contaminated. Again, the water cooler product provided 0 system pressure. The other brand name products created 12 and 25 pounds of standing pressure from the 5-time repeatability study at 200 degrees. So, in the end, with use with over 5 years with an IndyCar engine manufacturer, used as directed, yet success. We had success with stock steel blocks and engines used as in NASCAR. Success with aluminum engines used in the Indy V6 program under technical directive. Now, you have to remember, it's a steel sleeve in there for the piston, so you do have steel and aluminum or a steel block. All right. So success has been proven with multiple radiator applications and professional teams. Proven performance with heat transfer and system component protection. And finally, all right, the radiator had 5-time repeatability test by this qualified radiator manufacturer with 0 psi results from alloy gases emitting from the metal surface. It was amazing. The product that won was water cooler. As you can see, the advantages that it's able to provide. Further, In the short track application, which we've shown before, is here's a radiator after 2,000 racing miles, all right, with a stock block short track Chevrolet motor, aluminum radiator. It was clean after 2,000 miles. A directive was put out by the IndyCar manufacturer that at the time of the dyno, the race operations and all technical directive, that the water cooler was to be used. Here is a copy of the radiator at 4,000 racing miles. Here is that radiator again, 4,000 racing miles. Okay, clean, like brand new. The only reason they replaced it was because it was the end of the year. Again, water cooler, providing providing protection for the cylinder heads, for the heat transfer, the rust and the metals and the metal hydrates. Should you not want to use the concentrate, which is great for like 3 gallons, you can be able to use the water cooler premix, which is easy use, guarantee quality each time with a 5% treat rate with distilled technical water. This is a racing coolant product. It's not an antifreeze. Now, who uses this? Well, that IndyCar manufacturer is here shown. And what it was able to do was, here's a motor that's got to last for 2,500 miles, a radiator that's got to last until it gets hit, 4,000 to 5,000 miles, 700 horsepower, 12,000 RPMs, and a technical directive product with championships in 2012, 13, 14, 15, and 16. Now, if you wanted to use a qualified bio-based high-performance coolant, actual antifreeze, that product is the Aeromotive coolant, extreme duty formulation, and it has the same as the water cooler properties. You can see here that the antifreeze product, the bio-based antifreeze product, is good for 50,000 hours of operation, anti-boil to 300 degrees, unpressurized and antifreeze below 70 degrees Fahrenheit. An amazing product. The Aeromotive coolant program was developed in racing with proven durability, designed for military, marine, and commercial automotive, gasoline, or diesel applications, and extreme duty, long life applications from the desert to the winter operations. So that is the end of our presentation for the coolant system pressure control for metal surface protection with a qualified chemistry. As Wayne Lensing says, a racing radiator cleanliness and performance equals championship results. Should you desire to purchase the water cooler premix or the additive product, which is good for 3 gallons, please contact us at www.synmaxoil.com. Give us a call here in the Chicagoland area, 8815-389-9999. So on behalf of Wayne Lensing, Danny Lensing, Performance Parts Supply, the Left-Hander Chassis Group, including SynMax Performance Lubricants, we want to thank you for our time together. Should you have any questions, please do not hesitate to send us an email at office@aeromotiveresearch.com. We thank you, and we'll see you at our next presentation.